Hi, boys and girls. I hope you're doing great tonight. We are looking at Chapter 6, Lesson 7, Compare Fractions. In this chapter, you have really done a lot of comparing fractions already. Every time that we did equal or not equal, or equivalent or not equivalent, we were comparing fractions, weren't we? All right. So instead of equivalent or not equivalent, we're going to do greater than, less than, or equal to. Okay? And we're going to use a couple of strategies that we have already talked about. All right? So let's jump down here to number 8. Now the directions say, let me take a peek, just compare, right, less than, greater than, or equal. Okay? So I'm going to look at 2/5 and half, 1/2. 2/5 compared to 1/2. Now, one way to compare fractions is to find a common denominator and make equivalent fractions with the same denominator. Because if you have the same denominator, the parts are the same size, so you can just look at the numerator and compare them like you would compare any numbers. So if I wanted to think of 5 and 2 and think of common denominator, it's a common multiple, right? So let's list a few multiples of 5. So we multiply 5 to get a multiple. Multiple, multiply. 5 times 1. 5 times 2. 5 times 3. Okay? 2. Multiples. 2 times 1 is 2. 2 times 2 is 4, right? Okay? So far, do you see any in common? Nope, I don't either. I'm going to keep going on the 2's because I'm not anywhere close to 15. 8, 2, 4, 6, 8, 10, ding, 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 ring-a-ding-ding. I can use 10 as a common denominator for 2/5 and 1/2. Okay, so let's look at 2/5. We can make 2/5 an equivalent fraction that has 10 in the denominator, and we can make half an equivalent fraction with 10 in the denominator. Okay, because we just learned that 10 is a multiple of both 5 and 2. So 5 times what is 10? 5 times 2 is 10. What do we do to the, excuse me, what do we do to the 2? We multiply that by 2. What's 2 times 2? 4. So we just figured out that 2/5 is equivalent to 4/10, and then 1/2 is equivalent to how many tenths? Now remember what you know about half. Okay, 1 is half of 2. So what is half of 10? You know it. You know it. 5. Now let's just double check that. 2 times 5. 1 times 5 is 5. Okay, so half is equivalent to 5/10. So let me redraw that little circle. So when you look at 4/10 and 5/10, you can just think about fraction pieces or whatever you want to. 4 pieces of pizza out of 10, 5 pieces of pizza out of 10. Which one gives you more of those 1/10 parts? 5/10. You have 5 pieces that are 10th sized, and this one you only have 4 pieces. Okay, so if you have the same denominator, you just look at those as how many pieces do I have? Oh, 4 is less than 5. All right, let us look at number 9. Ooh, boys and girls, look at number 9. Now I want you to think 4/8 compared to 2/4. Thinking about 4 and 8. 4 and 8. What's 4 plus 4? 8, right? What's 4/8 equivalent to? Are you thinking? It's half, right? If I have 4 out of 8 pieces, I have half. Now look at this one. 2/4. What's 2 plus 2? 4, right? So if I have 2 pieces out of 4 that make the whole thing, I have half there too. 4 is half of 8. 2 is half of 4. Those are equivalent fractions. They're both worth exactly half. Okay? So let us look at number 10. Number 10, we could use a couple of different strategies. So I'm going to start off with the common denominator, and then we are going to use the strategy of greater than or less than half, our friend, the benchmark fraction half. Okay, so common denominator is first. Now this is number 10. The denominators are 12 and 4. Now remember what we said, if one denominator is a factor of the other, right? 4 is a factor of 12. So 12 is a multiple of 4. So instead of trying to find a common multiple, we have one right there. It's 12. I mean, you can list them if you want, just to prove it, right? 12 times 1 is 12. 12 times 2 is 24. And then multiples of 4. 4 times 1 is 2, right? There's 12. If one is a factor of the other, you can use that greater denominator as your common denominator. So we can just leave 7/12 alone and then look at 2/4. See if we can think of how to make 2/4 a fraction that's equivalent to something 12ths. So 4 times, what is 12? Times 3, right? And what do we do to the numerator? Make it 3 times bigger, because we made the number of pieces 3 times bigger. We have to make the number of parts we're talking about 3 times bigger. So we have 2/4 equivalent to 6/12, right? You probably thought of that because of the half situation, right? That's what we're going to talk about next. But let's finish this one. So if you look at 7/12 compared to 6/12, if you have a candy bar broken into 12 pieces, I have 7, you have 6 of those pieces. Who has more? I do. And I will share, though. I'll share with you. So 7/12 is greater than 6/12. Now the other strategy I was talking about, here I'm going to rewrite the problem down here. 7/12 compared to 2/4. You guys know that 2/4 is half. 2/4 is exactly half. 2 out of 4. 2 is half of 4. Okay? What's half of 12? Okay, half of 12 is 6. So 6/12 would be half. Now, is 7/12 more than half or less than half? Well, it's more than half. It's 1 more than half. So if 2/4 is half and 7/12 is 1 more than half, 7/12 is greater. So that's 2 strategies we used for that one. We used common denominator, and we used what we know about that awesome benchmark fraction, 1/2. All right, let's keep going. Okay, we are down at the bottom here, problem solving. Number 12. Now you read along with me, okay? A recipe uses 2/3 cup of flour and 5/8 cup of blueberries. Is there more flour or more blueberries in the recipe? So we are going back, 2/3 cup of flour, 5/8 cup of blueberry. Is there more flour or blueberries? Okay, so 2/3. I'm going to put an F up here for flour. 5/8. What was this? Blueberries. I'll put a B up there for blueberries. All right, let me think now. 2/3 and 5/8. Nothing is equivalent to half. They have different denominators. Here, we can even put the little circle there. What's the best strategy for this one? Because I don't think our benchmark half is going to be super helpful here. One thing I do know is that that's more than half, because 4/8 is half, so 5/8 is greater than half, and then 3 is an odd number. Oh, I know what we can do. Let's find a common denominator. Okay, so when we think common denominator, we think common multiple, right? So let's list some multiples of 3. Oh, look, I ran out of room. Okay, now let's list some multiples of 8. Okay, so we're counting by 3s, counting by 8s. Do you see anything that they have in common? No, I don't either. Well, we got all the way up to 32 on our 8s. So I'm just going to separate. I'm going to continue our 3s, right? So 18, 19, 20, 21. What's next? 1, 2, 3, 24, right? Okay. One more, 27. Okay, let's look again. Did any of these go with it? Oh, look. Do you see a common denominator? I mean a common multiple, which will be our denominator. Yeah, it's 24. Okay, so 2/3 and 5/8 can both be made into fractions that have the denominator 24. And I'll just squeeze this one in here. 24. Okay, we are going to make equivalent fractions here. So let's start with 5/8. 8 times what is 24? Well, if you forget, you can go 8 times 1, 2, 3. 8 times 3. How about 5? 5 times 3 is 15. Okay, so 5/8 is equivalent to 15 24ths. 2/3, so 3 times what is 24? Oh, we just did 3 times, didn't we? Right? 1, 2, 3, 4, 5, 6, 7, 8. 3 times 8. Gosh, I didn't leave myself very much room. 3 times 8 is 24. What do we do to the numerator? Multiply it by 8. 16. Okay? There we have 16 24ths and 15 24ths. Ooh, those are very, very close, aren't they, guys? Only 1 24th apart from each other. So after all that math, it's like, wait, what was the problem again? Let's go back. Is there more flour or more blueberries in the recipe? Oh yeah, that's why I like to do little labels like that. Because then look, we put that F there. I know the 16 is flour and the 15 is with the blueberries. So what's our answer? Is there more flour or blueberries in the recipe? Well, the answer is there is more What are you going to write, guys? Flower! Not a lot more, but some. All right, that was a good one. So now we are on the back, okay? This is number 2 on the back. All right, we're going to read it together here. Today, Ian wants to run less than 7/12 mile. Which of the following distances is less than 7/12 mile? All right, let's see here. 3/4, 2/3, 5/6, or 2/4. I'm going to look at 7/12. What do we know about 7/12? Okay, well, let's focus on our benchmark 1/2. Okay, thinking about 7/12. Now I just want you to decide, is that more than half or less than half? All right, so you need to think about what's half of 12. What do we double to get 12? Well, we double 6, right? 6 plus 6 is 12. 6 times 2 is 12. So 6/12 is half. So 7/12, that's one more piece. 7/12 is more than half. Okay? So which of the following distances? Oh, so we want to find something less than 7/12. And here's what we know, that 7/12 is more than half. So let's look at this list. Is there anything that we can eliminate immediately? Whoa, look at A. Okay. A says 3/4 mile. That seems like a lot. All right, I'm going to have to compare 3/4 by making it a fraction with a 12 in the denominator, because 3/4, we know that's also greater than half. So we can't immediately say, oh, that's it, because that's also more than half, just like 7/12 is. So let's do a little common denominator action. 4 times 3 is 12, 3 times 3 is 9. So 3/4 is equivalent to 9/12. Is 9/12 less than 7/12? No, it's greater than, isn't it? It's 2 pieces greater. All right, I'm going to do the same thing with 2/3, because 2/3 is also greater than half. So denominator of 12. Seems like we've done so many problems with 12 in it, right? 3 times 4 is 12. 2 times 4 is 12. So what I'm doing here is making a fraction that's equivalent to 2/3, but with 12 in the denominator, right? 3 times 4 is 12. 2 times 4 is 8. So 2/3 is equivalent to 8/12. Now remember, it's got to be less than 7/12, and sorry, 8/12. You are out. Okay, let's see. 5/6 of a mile. 5/6. Let's do another common denominator situation. 6 times 2. What do we do to the numerator? Times 2, right? 10/12. Oh my goodness. That's the biggest one so far. So let's look at D. Now we know D has to be the answer because we've eliminated the other 3. But when you look at 2/4, oh, we should have looked at that one first, right, boys and girls? 2/4 is equivalent to what? Half, right? 2 out of 4 pieces, that's exactly half. So we decided right away 7/12 was greater than half. So half is less than 7/12. But you know what the awesome thing is? We got some great practice comparing fractions with common denominators. I love it. All right. let's see what we are reviewing. Chapter 5, Lesson 3. Okay, we're going to we read first, then we reread. All right, let's see here. Sam has 12 black and white photos and 18 color photos. He wants to put the photos in equal rows, so each row has either black and white photos only or color photos only. In how many rows can Sam arrange the photos? All right, so let me go back and look at this problem. He's got 12 black and white photos, 18 color photos. He wants to put them in equal rows, and the rows can either have black and white only or color photos only, okay? So he doesn't want the photos mixed up. He wants a row of black and white and then another row of color photos only, okay? So in how many rows can Sam arrange the photos? So let's look at the choices. Look at the first number on every choice. 1, 1, 1, 1. He could do that, couldn't he? He could put one photo in each row and have a long, long list of photos almost, right? All right, so when I look at these numbers, I'm thinking about 12 and 18. And if I had to separate 12 and 18 into rows that were equal, I would have to separate them by the same number. I would have to divide them by the same number. So I have to find a number that both of them can be divided by, or a number that is a factor of both of them. Okay? Because if I find a number that I can divide into 12 evenly and 18 evenly, I can put them in the rows. So let's start here. Factors of 12. 1 times 12, 2 times 6, 3 times 4. I always like the number 12 because it's such a small number, but it has so many factors. I enjoy 12. 1 times 18, right? 2 times 9. Make this line a little bit longer. Is 3 a factor of 18? 1 plus 8 is 9, right? Remember your divisibility rules? 1 plus 8 equals 9. Is 9 divisible by 3? Yes, 18 is divisible by 3, right? 3 times 6. Okay. Anything else you can think of? Nope, those are all the factors of 18. Okay. So when we look, yes, they can both be arranged in rows of 1, but that doesn't help us in our choices, does it? Do you see other common factors or factors that are the same for both 12 and 18? Yep, 2. I see 2. Now let's look at our choices. Oh, look at B. B, you are out. And D, nope, D's in, C's in, A's still in. Okay, let's keep going. 1, 2, and 3 is a factor they have in common, right? Anything over here? Oh, you see that, guys? 6 is another factor they have in common. So is there anything else? Nope. So it's 1, 2, 3, and 6. Now let's look. 1, 2. Oh, look at A. Boom. 1, 2, 3, or 6 rows. Okay. See, D wasn't good because 4 is only a factor of 12. 4 is only a factor of 12. And B didn't have 2 in it. All right? Excellent work, guys. Finish up strong, okay? Persevere. Keep that brain chugging along.